Algebra 1 skills number 49, linear, quadratic, and exponential graph comparison. So a lot of this will be a review from things that we've seen in earlier slideshows, but it just sort of mixes them all up and lets you compare those. So first take a look at the various pictures. Linear, of course, graphs is simply a line which could have a positive or negative slope. Quadratic is a parabola, which could be like a smile or a frown. And exponential is flat on one side, steep on the other. This is a growth. We could also have decay, or you could reflect those and turn them upside down. Okay, y-intercept is something they may ask you about. In general, y-intercept is where the graph crosses the y-axis. But to find it algebraically, if you don't have access to a graph, you could put a 0 in for x. So because where it crosses the y-axis means it has an x coordinate of 0 at that point. So an example on that, this is an exponential graph. It's a growth, asymptote's at -3. What's y-intercept though is what I was asking. If we're not able to see it, we can put a 0 in the x position and algebraically work that out. 5 to the 0 power is 1. 1 minus 3 is -2. And we'll look at the graph to see that. There's the -2. Again, you see the asymptote at -3. You see that it's a growth as well. But y-intercept, put a 0 in the x position. Domain and range. Domain's all the possible x values covered by a graph. Range, all the possible y values covered by a graph. So for our three basic graph shapes in Algebra 1, if you don't restrict it, okay, that is, if you don't cut it off like in context, or if it's just a graph which is allowed to continue in both directions forever, the domains of all three will be what we call all real numbers, negative infinity to positive infinity. That's the concept of going forever to the left and forever to the right. The range, however, is not necessarily that. It is for lines. For linear, it will go down forever and up forever. But when you look at the quadratic and exponential versions, it will depend on the location of the vertex of the asymptote. Okay, let's look at an example of that. So what's the domain and range of this function? Now, we should recognize it's quadratic, therefore it's going to be a parabola. We should also recognize here this upward shift of 4 and the fact that it's a smile because there's a positive in front. Those are old concepts. Matter of fact, the graph looks like this. The vertex there is 0, 4. Okay? The domain is not going to care that vertex moved because it still goes left forever, right forever, but the range does. The range is a measure of all possible y values. Well, it never goes below 4. So the range is 4 to infinity. Now, you may or may not be used to this notation, what we call interval notation. You may in the past have said y greater than or equal to 4, but it would help to at least get some concept of what this is. This bracket means it equals 4, or it can equal 4, and 4 is the boundary, and this parenthesis here just means it cannot equal to infinity, because infinity is not a number, it's an idea. But regardless of that, you get some sense that it goes from 4 to infinity. Similarly, an exponential graph would also have a cutoff range because the asymptote prevents it from reaching certain y values. In behavior, okay, we're going to first look at the symbols. This infinity can mean up or right, and this negative infinity can mean down or left. Okay. Now, in behavior may be one of those things that's not put as a huge priority, but it would help to have some concept of what it is. In behavior is just simply what happens as the arrows leave the screen, so to speak. If you have one of those graphs which lines, parabolas, and exponential graphs will leave the screen and continue forever in a certain direction. It's just talking about which way it's going, okay? And it certainly helps to understand some concepts of what graphs look like because you may not have a graphing utility available to you at all times. Here's an example of that. What's the end behavior of this linear function? Now, we should recognize it as linear. X to the first power. X is not enclosed in some special symbol. We should also recognize this negative slope here. Okay, so this graph is going to be up on the left and down on the right. So I'm going to hold the picture for just a moment, let you think about that, which way the graph goes. But the end behavior, you could do it formally or maybe at least just have some concept of it. Just sort of informally, you could say on the left it goes up forever, and on the right it goes down forever. Okay, just again, picture that. We'll look at the picture in a minute and come back to that. But that, at least have that concept. It goes up to the left or down to the right. Now I'm going to go ahead and show you the formal look there. A lot of people don't memorize this, so don't worry too much if this looks confusing. But as x approaches negative infinity, that just simply is a fancy way of saying as you go forever to the left, f of x, which is this, similar to y here from a graphical standpoint, goes up. So on the left, you're going up. That's just a fancy way of saying that. And on the right, as x goes to positive infinity, you're going down. Okay, we'll take a look at that graph to see that. Of course, there's some things you should recognize. Y-intercept 3, negative slope, down 2/1. But it's going up on the left. That's what this is saying in these positions. And you're going down on the right. That's what we say here and here. So that's in behavior. Okay, just a quick look at our shifts. Just a reminder, add on the outside, you go up. Subtract on the outside, you go down. Add on the inside, you go left. Subtract on the inside, you go right. I would definitely have that memorized. And then the stretches and shrinks. Stretch would be if you would be steeper or more narrow depending on the graph. It's multiply the entire function by a number whose absolute value is greater than 1. And the vertical shrink, flatter or wider, multiply by a number between 1 and negative 1, like 1/2, for example.